All right, guys. So I'm gonna solve a couple of the sample questions for the final exam of the discrete maths questions exam. So let's see for the first exam question is this one. So we see that this recurrence formula, and we're going to find the homogeneous solution. Actually, this recurrence formula is the homogeneous one because there is no term after here. So there is no constant, or there is no term without independent from any S sub n. So we see that to be able to solve this one, we constitute the characteristic equation, which is this guy here. And from here, we see that r squared, if we get everything on the left-hand side, we see that 2r minus 15 equals 0. So from here, if we decompose this polynomial, the quadratic polynomial, we see that we will have minus 3 and r plus 3, r minus 5 equal 0. From here, r is minus 3 or r is 5, 2 roots. As a result, the Sn will be coefficient C1 minus 3 power n plus C2 times 5 power n. So I think actually definitely part B, option B is the answer. Now, let's see this question here, and we have been asked to find the particular solution because it is non-homogeneous one because of this term here. And since this term is 2n, a polynomial of degree n, of degree 1, so the particular solution for this one will be like an plus b. So we're going to sub this S and P in the original recurrence equation, and we will be able to obtain A and B. So we see that an plus b 2 times a n minus 1 for, I'm talking about this one. So plus b plus s sub n minus 2, which will be plus b plus 2n. From here, I need to expand the right-hand side. So I will have, then I will compare the coefficients of the n, and the constant parts, and I will be able to obtain a and b. So I have 2an for this part, all right, and minus 2a plus 2b, and from here an minus 2a plus b plus 2n. If I factorize, actually, if I gather the n terms, the terms including n, I will have n times 3a plus 2, which will be, again, after this, this guy and this guy, and of course this one. So these will be constant terms for me. So 3b minus 4a. Now with the comparison of the coefficient of this n will be equal to this one, and the constant part will be equal to this part. We see that 3a plus 2 equal a, and from here a is equal to minus 1, and the constant part b equal 3b minus 4 times a, which is minus 1. From here, we see that minus 4 is equal to b. As a result, b will be minus 2. Therefore, SNP will be a n plus b, which is equal to minus n minus 2, which means first option is the solution. All right. So question 3. So we've been asked about the 5 people attend a party and leave their coats at the door as they enter, and their friends return the coats to them when they leave. So in how many ways it is possible to see that when their friends return the coats in such a way that no guest leave with the coat in which they arrived? So this means the arrangement notion. So we see that we've got 5 people here. So the answer is D sub 5. From here, 5 factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial and 1 minus 5 factorial. From here, so I can cancel these two. So 5 factorial times 2 factorial will be 5 times 4 times 3. The third, this term will enable me to write 5 times 4. And this guy, I will be able to write plus 5. From here, I will be able to write minus 1. So I've got, so this guy will be 40 plus 5 minus 1. So 44 is the answer. All right, question 4. So the question 4 is about the drawing 4 cards. So whole scenario will be, we will have 4 cards here. If the 4 cards are drawn at random, and from the deck, what is the probability? Precisely 2 of them are ace. So exactly precisely 2. So because we have 4 aces, and we have 4 a deck of the 8 cards consists of 4 aces and 4 kings. So we've got 4 kings. Okay. And if I draw 4 of that, all right, so it will 4 cards are drawn by chance without caring about the order. So the answer, so draw a card by randomly, it means C8 4 or 8 4, considering whole scenarios. It will be 8 choose 4. So exactly we have 4 aces, and if precisely 2 of the cards are aces, so I need to choose 2 of the aces from 4, and the rest it will have to be like choosing 2 cards from the king cards. So it will, they are 4, so I can choose 2 kings from 4 kings in 6 ways, or 4 choose 2 ways. So from here, 6 times 6, and if I calculate this one, this will be 70, and this will be 18 over 35 after simplification. So the answer is part B. So drawing a card is C8-4. So it's not P8-4 definitely. All right, question 5. So you got this one, and this question, the outcomes of the die is 6 faces, obviously, and you're gonna constitute a random variable x, which is coming from here. So n is the number of the faces from a die, and the random variable is has been defined like piecewisely like this. So here is the, we are going to like obtain the average or the mean of this random variable or expectation of x. So we have that in x, p of the x, we need it because for calculating expectation of x. So 1, 2, 3, 4, 5, 6. And if I have 1, so it means 1 is odd. So 1 plus 2, so here 3. 3 here. So 2 even, so 2 plus 1, so I will write 3 here. And 3 here, 3 is odd, so 3 plus 2 is 5 here. And 4, if I get 4, 4 means even, and 4 plus 1 is, so 5, 5 here. And respectively, these two guys will be 7, 7. All right, so the probability that to get 1, phase 1 is 1 over 6. So there is another 3 here. So x can be, in two scenarios, can be 3. So 1 over 6 here and 1 over 6 here. So for all of the faces of the die, it's a fair die. So the random variable for this one, x can be 3, 5, 7. So this will be this guy 1 over 6. For 3 will be 1 over 3. And this one is 1 over 3, and this one is 1 over 3. Now, the expectation of x, or the mean of the x, or the average of the x, will be xi, probability of the x, xi, I from 1 to 3. From here, 3 times 1 over 3, plus 5 times 1 over 3, plus 7 times 1 over 3. And the answer will be 5. Okay, so this is the expectation of the random variable x, and the answer is 5. Now let's go to question 6, and we see that we can see that this part A, it has got this we have been asked to say that whether this function is injective or one-to-one or not. Okay, so from here we see that the answer, we see that this should be x. Okay, and the horizontal line test tells us that the injective function should cut the curve or function at most at one point. So this test show that the function is not injective, and we can actually, we don't need to prove this one. For we can give a counter example. We say that if x is equal to 2 and x equal to minus 2, so we can get f of x, f of 2 is 8, and f of minus 2, 8. So the injective should be like when y1 and y2 is the same, then x1 and x2 should be the same, while this is not true for this function. Part B, surjective. Yes, surjective. The range of the function is this one, so it's surjective, and it covers all of its range. So, but we can write like this. So let y equal b be an arbitrary number in the range of the function. So we want to find, x such that f of x will be b. So so it means there will be a, so this means image of the function will be equal to the image of the range. So we see that from here, we see that 2x squared will be b because of the definition here, you see that f of x is 2x squared. So from here, x will be plus minus square root of b over 2. So if we choose positive or negative square root of b over 2, we will get b. So this means the range of the function, the range image of the function is exactly range of the function. So f is surjective. And for the part C about, I'm talking about this one. So is there any function? So G, so actually you can say just no, because f is not injective. Or you can just give write an example. So if x equal 2, then we should go to the 2, 8. If I have f, if I apply f, we should go to the 8. And from if I apply g, then this will be g of f. From g of f, I should go to the 2. But f of 2 is for sure is 8. And g of f, g or f of 2, which means g of 8, must be 2. But then g can be like g of x should be x over 2, and this will be square root of 8 over 2, 4, and this will be plus minus 2. So actually we cannot find a unique one. So but so we cannot find definitely a unique function. And this there, and another problem is here that you see that this should be like, if we have the square root of 8 over 2, it will give us plus minus 2. So that's why it doesn't, we won't be able to have this one. Okay, so we cannot guarantee that we will get of course 2. Maybe we might get minus 2. So we cannot find something a function something like this. All right, question 7. Part 7, part A is like Mississippi. So 11 letters. In how many ways we can permute this letter? So permutation with the repetition. So it will be 11 factorial. All right. And we've got I, and I. So 4 factorial here. And we have 4 factorial for S, for I, for S. You got 2p, 2 factorial. And we've got 2p, and we've got 1n. So this is the answer of part A. Now, part B, we see that 3 letters. So it can be distinct letters, X, Y, Z. So we've got 4 types. So all of them should be distinct. So the answer is 4, choose 3. And we see that the times 3 factorial. All right. And this will be for the scenario that we've got X, Y, Z. So I can choose, I have 4 types here, and I can choose 3 of them. So this can be done by writing 4, choose 3. And these X, Y, Z can be like ordered in 3 factorial ways. So this and this is the way. And because in the writing the letters, the order is important. So 3 factorial for 3 objects. So this will be the permuting 3 factorial 6 ways. And another scenario will be 2 of them repeated like this. So in how many letters that we can repeat twice? So we've got only ISP. So ISP, and we cannot do for M because M has like it has been repeated. It has just we've got just one time M. So the answer for this part will be choosing one of the letters among 3 options, and then for the Y, then after choosing ISP, let's say I, then we will have 3 options to choose for the other one. So this will be in 3 ways. And again, and not times 3 again, because this can be permuted in 3 ways. So it is, in fact, this can be like YXX or XYX or XXY as default. And the way that we can get XXX, or all of them have been repeated, same thing is only for I and S. So this will be just in 2 ways, and this in these 2 scenarios. So the all in all, the answer will be, let's do here. So this is for here, and this is for this one plus here. So all in all, the answer will be 4 choose 3 times 3 factorial plus 3 choose 1 times 3 times 3 plus 2. This will be the answer of the part B for writing 3 letters, choosing the letters from the word Mississippi. Now, let's do question 8. All right. So question 8 is, we've got 52 cards consist of 4 Swiss club, diamond, hearts, and spades, and 13 denominations of each. So you see here, and a poker hand consists of the 5 cards drawn randomly from the standard deck. The order in which the cards are drawn is not important. So the order is not important, so we are not after for the permutation. So for part A, we see that it is 52 and just choose 5. All right. So for part B, we see that how many poker hands with precisely 2 aces. So it means this one. So choosing, we've got, of course, 4 aces. So choosing 2 of the aces times the 2 of the cards will be chosen from the rest of the cards, which is 48 of them. So 48, choose 3. This will be the answer of the part B. Move on, question 9. So for the question 9, we need to use the random, binomial theorem. The binomial theorem tells me that for an integer n not less than 0, we've got a plus b power n is equal to k running from 0 to n, choose n choose k, a power n minus k, b power k. So if I apply this one for this expression, so we see that x minus 1 over x power 10 equal to sigma k from 0 until 10, 10 choose k, x power 10 minus k times parentheses minus 1 over x power k. So we are after for this coefficient of x power minus 4. So we see that k from 0 to 10. 10 choose k, and I should simplify this. So we've got that x power 10 minus 2k. So so since x power minus 4, so 10, we are after this one. So 10 minus 2k should be minus 4. From here, 10 plus 4, 2k, and from here, k must be 7. So k must be 7, all right? So this will be 10, choose 7, minus 1, power 7. Okay, so this will be our answer for this question. Okay, so move on for question 10. A box contains of the 4 red balls, all right, and 3 black balls. So 2 balls are removed at random without replacement. What is the probability both balls drawn are red? So we see that part A must be choosing 4 red balls among 7 balls times. So without replacement, so one of the balls have been decreased. So we've got only 3 reds and totally 6 balls. So it will be 3 over 6. Part B, so we can have 1 red and the first one red and second one can be black, plus in this the other scenario can be like first black and second one red. From here, so we see that probably first red, it is 4 over 7 times the second one is black, so should be 3 over 6 plus first black, it will be 3 over 7 times second red, so it will be 4 over 6. And this is the answer of the part B. Now, question 11. So we've got 13 players choosing among 17 players, 2 of which can be Nico and Dali. So what's the probability that both of the Nico and Dali are chosen to be in the team? Both, so we need to separate, assuming that actually Nico and Dali, they are in the team, and we need to know that how many scenarios for the rest. So in fact, the probability of the Nico and Dali to be in the team should be actually their existence or intersection of being both of them in the team. So which is equal to, the whole scenario is obviously 17 choose 13. And if I choose N and D, of course, in the team, the rest will be 15 choose 11. Now, part B is about the conditional probability. So what's the probability that the Dali in the team, given that Nico is already in the team? So probability of the condition N is equal to the intersection with the N, the intrinsic definition of the conditional probability of N. So we already have the knowledge of the value of this one. So we need to know about the probability of the N. So probability of the N is equal to whole scenario is 17 choose 13, but so the desired space is this. Nico will be in the team, so I need to know the rest of the scenarios, how many ways. So it will be 16 choose 12. So if I combine, if I substitute this value here in the denominator and this one here, so the answer will be, maybe I can do some simplification. So it will be, so this guy can cancel each other. So this will be 15, choose 11. And 16, choose 12. And you can do the simplification, of course. All right, move on. Question 12. And question 12 is a familiar question for us. The probability of the male and approver. Okay, so this is like 62, obviously 62 divided by whole numbers, 62 plus 27 plus 45 plus 53. But the rest of the question is, given that the person approves, so the condition is like yes, approving, all right, or my world or whole sample space, whole scenario will be restricted to the approvers, yes. And what's the probability if the approver is female? So female condition approver. So this will be 45 divided by 62 plus 45 is the answer of the second part of the question. Now, question 13. So we've got this question 13. So there is a box, three identical red, three are identical. So I should change the color of the box. So I've got 3 red envelope and 4 identical black. And I've got here 2 of the red envelope contains a gold coin. So here, and what else do I have? And a silver coin here, for example. And in the black envelopes contain a gold coin and 3 silver. So 3 silver and 1 gold coin. All right, so the question asks us to A1B, the event of the drawing a red envelope. A2 is the event of the drawing a black envelope. B is the drawing a gold coin. So it says that verify the total probability. So the total probability, so actually it will be probability of, so should change the color, actually green, probability of the B. So it should be probability of the B intersection A1 plus probability of the B intersection with A2. And this is equal to probability of the B condition in the world of A1 times probability of A1 plus probability of the B condition A2 probability of A2. Now, probability of the B, so let's do right here. Probability of the B is, we see from here the gold. How many golds do we have? 1, 2, 3. So 3 out of 7. So 3 out of 7. probability of the, what else do we need actually? B gold among the red packets. 2/3. B condition A2, it will be 1/4. All right. So, and also we need to have A1. Red one are 3/7, and black envelopes are 4/7. So probability of the B is this one. So maybe better to change the color. 3/7. And the rest I will substitute whatever I have obtained here. Okay, simplification sum 2/7, 1/7, which verifies the total probability formula, because this one is equal to probability of the B, which we can obtain it actually from this simple question or problem independent. Okay, move on. Question 14. So, yeah. Find the probability of the function of the number of the fours. So, part A, we see that the desired, actually, this is the Bernoulli distribution. So, 4 of the 20 rows will be 4. Number of the, so probably number of the fours. Okay, so this will be probability of the K of that. So this will be 20K, 1/6 power K, and 5/6 power 20 minus K. This is the Bernoulli distribution, or Bernoulli probability density function. Using this, we can solve the part B. So less than 2, so it means probability of the 0 plus probability of the 1. So this will be, so K equals 0 in this scenario, it will be 0, 0, so it will be only this one. Plus 1/4, so it will be 1/6 power 1, 90. This will be the answer of this. Part C, so what's the probability? At least 1/4. So 1/4 means probability of 1, 2, all of that, 20 rows. But this is a little bit hard to do this one. So we can do 1 minus probability of the X minus 0. So with this trick, you can obtain the answer will be 1, 5/6 power 20. And it's good that we have obtained this one, this guy here already. All right, so move on. Question 15. So we can see that the tree can be obtained like this. All right. So it will be like this. 1 over 3 h 1 over 3 h, and this guy is h. We can have this one, we can have this one, we can have, and also maybe we can have, yeah, 1 3. So okay, and we can have this one here, so we should have like ht ht. So we should have 8 scenarios. So this one is h, this one is t, this one is t, this one is t. So I hope I didn't miss anything here. And you can easily fill the numbers, of course. I do one of that. 2 over 3 and 1 over 3 for here, 2 over 3 for here. So they are independent. It doesn't change anything by rolling the the tossing the coin several times, the independent probability. Now part B tells me that probability of the random variable x. So the random variable of x is the number of the tiles in 3 tosses. So it will be k equal to, it's again the Bernoulli distribution. So this will be 2 over 3. The coin is biased, k. 1 over 3, 3 minus k. And so actually this is part B and C. And for part D, it says that actually the C, I can do that, and D as well. So we need to say that, all right, let's do this. C is here. So x equals 0. Okay, so if I substitute k equals 0, I will get 1 over 27. Probability of the x just one time tile, it will be 2 over 9, or times 3, it will be 6 over 27. Probability of x like twice 2 tiles, it will be 4 over 9, or equal to 12 over 27 tiles. And probability of the x equal 3, it will be 8 over 27. So it is easy to plot this one. So we see that 1 here, 2 here, 3 here, and I think I should amend this one. So here, so p of x here and x here, and we see that this should be like this, 1 over 2 over 27, and this will be 6 over 27. This should be like twice of this one, because it's 12 over 27, and this should be between 6 and 12 because it's 8 over 27. All right, so this is the last question for part D, and you see that how we are able to solve this question 15. All right, I wish the best in your final exam.